You can totally spoof these. It's literally a header in the thing that you can send. If you don't have, you can get extensions for your browser to say, I want to send the user to this. You can intercept it with a proxy, or you can just set this up. So, to go back to cookies and just to reiterate what they are, since HTTP is stateless, if you want to have a stateful application for members of the user, you need something to preserve the state. In this case, it's a cookie. It's a piece of data that the web server will give you that proves that you are you after you authenticate. Once or whenever you reach out to a certain domain, your browser will automatically send all the cookies that are associated with that domain. So let's say you've logged into example.a.com, example.b.com. You make a request out to example A. You will send any and all cookies automatically for example.a.com over to that domain. You will not send any other cookies, including the ones from example.b.com. And the same thing goes in reverse if you were to reach out to B and send it. So there's something that's kind of big in the web world called the same origin policy. So to go over that, an origin is a combination of the host you're going to, so like taking the IP address of the host name, the port you're contacting over, and the URI that you're requesting a page from. And if you're not familiar with the URI is just like the slash notation at the end to show which page you are, whereas the URL is the entire like HTTP : / the host that you want, whatever port you're going to. And then like the file, that's the entire URL, but the URI is just like the file path. So all of those together define an origin. And the same origin policy states that in order to load a script or another resource, it has to come from the same origin. It has to come from the same place. This is to limit the effect of, someone trying to put something malicious into the page. But the thing is, this is entirely client-side. Right? So this is something that's been enforced by the browser. This isn't something that the server is going to be handling and checking like, oh, well, there's really no way that you can check it from the server perspective. Because if I'm the good server and the Jesse over there is a bad server, if you request a page from me and I have a link over to Jesse's server and I didn't know it was there, it's subjected to the page, how am I going to stop you from going and reaching out to that page? So this seems like it'd be kind of limiting to like web developers, because how am I going to host all of my resources on like this one site? There's something called cross-origin resource sharing, which allows you to explicitly state that I'm going to allow like this domain is going to be all my utilities, like my CSS and my JavaScript and my JavaScript libraries, versus this like domain or origin is going to be for like the HTML. So you can kind of get around that and structure your server architecture to reflect what you want to do, and the browser should agree with that. So let's get to HTTPS. It stands for HTTP secure. So by secure, the only thing they really mean is that they've added a layer of encryption around the protocol. So HTTP is entirely clear text. If I go log into a simple authentication form and say the username is Nick and my password is password, anyone who's stepping on that can see. HTTPS uses TCP port 443. It basically just wraps the entire thing with SSL and TLS into that right now. So SSL TLS, what is it? How do you? It's a full encryption suite, all the way including asymmetric encryption, certificates, certificate authorities, secure key exchange for symmetric key encryption, and then hashing for integrity monitoring. SSL stands for Secure Sockets Layer. That's now been entirely deprecated. It was first released with version 2 in '95, but there were some problems, and eventually a rewrite was done around, I think, 2001 for TLS. TLS 1.0 is equivalent to SSL version 3. SSL has been deprecated, and TLS 1.0 is legacy now. You'll still see it out in the wild, but you really shouldn't be using it. You should be using either TLS 1.1 or 1.2. 1.3 is in practice right now. Yeah.
You actually shouldn't be using 1.1 either, but this is actually strictly 1.2.
Okay. So strictly 1.2 on that. So to kind of go over how SSL and TLS work, there's like a handshake, just like speed has a handshake. So in the beginning, you'll see the client is going to reach out to the server that you want, and it says hello, and like here are my supported cipher suites. then the server is going to respond to that and say, okay, here's my certificate, here's the thing that proves that I'm me, and here's what I support. The client's then going to check that, see if that works. Like if they do support like some crazy algorithms that like, we don't support, obviously you can't communicate with it. If all that works, they exchange a symmetric key over the asymmetric encrypted channel. And since symmetric encryption is faster, much faster than asymmetric encryption by nature, you want to do all of your transactions with a symmetric key so that you can get everything done faster and less overhead. So you exchange the key, and that's determined. We're going to do that in a sec. And then you send over your secret key information. The server will then say it's finished, or both parties will then say you're finished, and then you use this symmetric channel to exchange whatever messages you want. So you're using the asymmetric encryption to one, prove who the other party is, or prove to each other who you are, and then you're creating a much faster encrypted channel to actually send data. So I said something about certificates, right? A certificate in like the real world verifies that you can do something. If you take a certification for like a course that gives you a certification to be like a penetration tester, you get a piece of paper, it's something. You're going to college, you're getting a degree, you're being certified to be a security student, or a software engineer, or a computer engineer, or something. It's something that proves that you have certain attributes. And the same thing applies to computing. We have these TLS certificates that verify that you are who you say you are. If I go to Google, I want to be damn sure that I know I'm actually going to Google and not to China's like government's of Google, and then they're stealing all my searches. This is just essentially a data file. It contains the public key of the server, a whole bunch of other information, and then it contains like an encrypted hash of that entire certificate that's been encrypted with the public key. So if you were to compute the hash of the entire certificate and then decrypt the hash that they gave you that's encrypted with the public key, they should match. If they match, you know that the certificate is valid and has not messed. If they don't match, something's wrong with the certificate, and that's what only generates the warning that you see up in the browser. Something is not right. So there's this idea of certificate authority. So to go back to like you getting a degree, RIT would serve as a certificate authority. They have the authority to say, yes, here's a piece of paper that says you are qualified as a computing security major. There you go. Right? They manage who they say has those skills. The same thing applies to us. You have a group of servers that say, yes, I am me, and you trust me because I'm a certificate authority. And I'm going to vouch for Google and say that Google is Google. You trust me, you should trust Google because I trust Google. It's kind of like a chain of trust hierarchy. And there's whole networks of these in like a top-down fashion. There's multiple. Okay. So like some of the big names you might hear like Komodo, Symantec, Bodhi, Global Sign, and Digiser. They manage most of like the certificates in the world. Those are the top 5. Normally that process to get a certificate is like kind of like long and arduous, and I feel like just log it can be a pain. You often have to pay for the certificate over and over again. So people in 2014 under Let's Encrypt, it's a free and open source. So it's supposed to
The process to create certificates.
oh yeah, the whole algorithm behind it. It's a free service that allows you to create a temporary certificate that you can use. And you provide a domain, and you can utilize it. It makes securing the traffic for your sites just a little easier. So, we've done over certificates. We're going to get more of the basics. I know there's a lot of basics here. It's just that web is ginormous. Who here has heard of an API? Okay, a lot of you. Who here has worked with a web API, like programming? Okay, a little less. So for those that don't know, the common web API standard today is to use something called a RESTful architecture, or a representational state transfer. Essentially, it's just a way of organizing your web servers or HTTP API endpoints to act in a certain way. So with an API, instead of hitting a web page, you're going to hit something called an endpoint. So that's going to do a function. So if you're going to get like index.html like a regular website, you're going to be getting a page. That's what you get. In an API, you might be doing like an action on a data set. So when you're testing these, you're mostly going to be looking for like software and logic vulnerabilities, and not mostly like cross-site scripting and SQL injection. If the API does interact with the SQL database, you can obviously potentially do SQL injection, but normally, like what you think of as web, like cross-site scripting and stuff like that, doesn't really apply to APIs because you're taking it out of the browser and working with a service over that. So if you're going to illustrate how you should organize the rest of the API, you should use like sort of nouns in like a plural form. So like at this point we have like cars. If you were to get that, maybe it would return like a list. If with get, you want to like only get information. You should do most of your actions, so when creating things with post requests. So like update a whole bunch of files or something, you should do like a pull request, and then you should use a delete request. So it's all taking those methods that you've known from HTTP and putting them to use in like a programming function. Then if you want to get like a specific kind of thing, you can specify like the ID of the card that you want in this case. Get it back to you, and then you would either update something, but with a post. In this case, it's all dependent on how you structure it. So finally, we've gotten through all of this stuff where I touched with you guys about that. Let's break this down. Back to cross HTTP. Okay, no. No, we're not. Wait, I can do more than a alert box? What is this stuff? So, you've done your testing, right? You've gotten to a web page. You figure out that, okay, I've got cross HTTP. What can I do? This alert box only just, pops an alert. It's like your test. But what can you do? So what you can do is you potentially load or remote script. So you just do a script tag, make the source over to whatever address you want to pull down from, and you can run that. Maybe if you're like in a space limitation, you can use a short URL to pull down a link and then run your own script without looking too over. An example of this is the browser exploitation framework. I'm going to talk on that at Sparsa. It's not quite updated anymore, but it's essentially a framework for getting, if you have social, or if you have cross-site scripting, you can use it as a social engineering and then exploitation framework to get onto the browser and use the browser as the function for so one of the things that are like directly doable on the page, what if you wanted to steal someone's session, right? That's something that you want to do. Maybe you know the admin is logged in and you're not admin. You really want to be an admin. Just reach out, right? One of your admins. How do you prove that you do that? Well, you go back to cookies. The admin has a cookie. You have a cookie. Your cookie is not the admin's cookie, so you don't need to do admins. But if you use the admin's cookie, you might just maybe be able to like do admin stuff, just to like make you feel all warm and fuzzy inside. So, so we have our like ability to inject into the page. What we're going to do in this case, we like create an iframe. What an iframe in a web page is like, think of a web page and then like make a tiny web page within the web page. So we have like kind of like we do virtual machines, but you're shrinking the web page and the web page. What we're going to say is, okay, make the width, the height, everything. We're going to shrink it down to absolutely nothing so no one can see. Right? Then what we're going to do is we're going to call window.load, and that accesses like the window that you have right there. And we're going to tell it to load whatever. We're going to make it to load to address. So like, let's say I own people.people, right? And I own that site, and I'm going to make a request out to people.people/ and then the cookie that we want, right? So it's making a request to an endpoint that doesn't exist. But if you were to go and check your logs over on that server over there, you would see that a request had come out for this, in which you would know that that's a cookie because you know the script. So then on your own server, you can be like, well, I got that. And then you go over to your client or your browser, you swap out the cookie that you have for that one, and then you log in the server. This is a way that you could steal someone's session. And there's much more you can do with cross-site scripting. There's a ton of resources out there, and I highly encourage you to go out and look at them. You can do crazy things like create keyloggers, do browser escapes, or form exploits within the browser. When you get cross-site scripting, you have access to pretty much everything JavaScript can do, which is like the full programming language. So you can really do anything you want to create. If you don't have the space to put that in the page, you can post the script somewhere remotely and then call it down. You just have it run. So, cross-site scripting is not only crazy, right? It's not like I can just put a script tag anywhere and be like, yo, leave an export, I got cross-site scripting, bunch of roasting. There's often filtering. So people know that cross-site scripting is bad, and we want to make sure it doesn't happen. So what do we do? In the most easy and naive case, you gotta put in a tag, right? You gotta say, like, this is like HTML injection area. You gotta put in a script tag to make it do script stuff. Or like, you're not gonna throw an image in here, so I'm not gonna let you do that. So, from a naive way, you just like take those two bracket characters and just make them not do that. In theory, it should work. So, let's just take a basic example, right? We've got, let's say that this filter is looking for a script tag. And script tags are bad, and we're just going to get rid of them. So we put in this. Those two things right there determine that. But in the middle, it's just text, right? We don't care about anything else other than like, we found a script tag. That's bad. Let's get rid of it. So we get rid of it, and we just have some text, and everything is fine. Well, this is a pretty simple scheme. They're only checking for like one thing, and it seems kind of dumb. So let's see if we can pass that. So what if I took a script tag and then put it in a script tag? Done. So we see that like we've identified that this here and this here are bad. So let's get rid of this, right? But what do we end up with? Something that's still bad, right? So cross-site scripting prevention can be kind of tough. And the whole bottom line here, before I get into anything else on the page, is use standard libraries. Okay, use standard escaping libraries. These rules that are from taken basically directly from the laws, when you get input, you're supposed to never ever trust it. You're supposed to take the HTML and escape it. You take attributes, you escape that. You take JavaScript, you escape it. You take CSS escape. Basically run through every possible escape recursively to make sure you've gotten rid of anything that could potentially be bad. And like one thing to think about this is like, okay, if you're doing all of these things in order, well, what if I just like put one step out of the order? Any algorithm that someone has could potentially find flaw. These standard libraries are really pretty robust as long as you use the right ones. But with a bit of work, you can get through it and you can find some sort of ways to pass it. That's how you do it and how the algorithm is. So, on the cross-site request order. Who has heard of cross-site request order before? Okay, who actually knows what it is? Okay. Who has had cross-site request order explained to them before and they still don't know what it is? Okay, yeah. Here's what happens, like, pretty hard. It took me forever to, like what that heck is going on. So, the law's definition is a type of attack that occurs when a malicious website, email, blog, instant message, or program causes a user's web browser to perform an unwanted action on a trusted site because the user is currently authenticated. That's a lot of words that come in all of your head. TLDR, we're going to trick the victim that doing something they don't want to do for somewhere else that they're already authenticated. How is SpongeBob? Oh, it's also called CSER sometimes.
Clever. Clever. That's what 2 a.m. gaming gets you.
So,
I have a vote in the comments.
Thank you.
You have to get something on
Get us money.
You don't need cross-site scripting to do this, but this is the example. We're going to go over a lot of documentation on this. If you get anything from either of these presentations, is if you don't know anything of what I'm saying, go look at the law and just like read through wiki pages for a while. Mike is shaking his head. Mike is shaking his head. Oh, it's got a lot of information that can be overwhelming. So our example is we have HTML injection. We're able to inject something onto the page. So if we were to put an image onto the page and say, okay, yeah, image is like over there. And like it's over at that bank that you have. And you know, we're gonna go to the transfer money endpoint, and then we're gonna say, let's just transfer over to the attacker, and then let's transfer over 9,000 money is to you. In this case, what you're doing is on the page. Your browser is going to go and attempt to load that page, but since that's just like an endpoint or something that's performing action, whenever it receives those values, it's just going to do it because you essentially call a function by passing it to an index. Does anybody not know what I meant there? You can raise your hand. It's okay. Somebody.
I'm gonna raise my hand.
You're going to raise your hand. What didn't you understand, Luke?
Oh, well, if I was somebody sitting in this room and I didn't know, I don't know, what is the value supposed to be?
What is the value supposed to be?
Yeah.
Of what? Like the value of
URL. The URL, what does the number mean?
Okay, so in this case, we have like a bank that's set up. We're like transferring money. And let's say we want to transfer money to a bank account. We want to transfer this much money. In this case, you have authenticated to a site that's been like modified by an attacker. And that attacker has told you that you should go over to that bank site and transfer money to them, which is bad. And since you're authenticated, you're just going to do it because when a browser renders a page, it just goes, okay, there's an image over there. I'll go and do it. So we're going to get into this with more fancy diagrams and such. So we've got two websites. Okay, you're going to go out, you authenticate people. All is good with the world. You're a regular person who's browsing the whole thing like tabs at the same time. We got scumbag Steve over here. He really wants to steal your money. Okay, Steve. So he goes over and he gets some sort of HTML injection. It's something on like a page that you might go to that like forces you to go do something you don't want to do. You go out to visit that page. You download whatever like he's added into that page, which forces you to go somewhere else over to your bank, right? You're making a request without knowing that you're making a request, because in the previous example right here, if you look, we're just loading an image, right? Something that's innocuous, something that it's just going to go out and do automatically, and it's going to hit that endpoint. Remember when I talked about APIs, it's basically just a programming interface over HTTP? You're basically calling a function through downloading an image. So we go back over here, and it's essentially telling you to go out and make this request, take your monies, and send it over there. Yes, Dave.
So with that API, we want to use post requests and not GET requests.
So at that point, it could be a little bit harder. In this case, we're just using, like, we're assuming that, like, in this case, it's a GET request. You can supply parameters at the end. With a post request, it's going to be harder because you need to find a way to set a value in the post request that you're sending. I don't know off the top of my head how to do that with just like a straight request.
So one thing you can do, you can make an HTML form and just say it's on this.
Yeah, okay. So if anyone doesn't know what an HTML form is, it's like, you know, when you have some text boxes, you have like a button that you click and like, that sends it. You can send values over.
So victim needs to already be logged into said bank and have a tab open when they browse the website, right?
Yes, they have. Well, they don't necessarily have to have the tab open if the site isn't like if the site hasn't like knocked out their session and said you're not allowed to make
Like
it.
expired yet?
Yeah, the cookie hasn't expired yet. So as long as you have an active session from the server's perspective, you go to that page, you can like make that authenticated action. So to put it simply, if you make authenticated endpoints that perform important actions accessible to your GET requests and URL parameters without any mitigations, you're going to have a bad time. So how do we prevent this? This is kind of wacky, but what is this whole process? How do we prove that you are supposed to be on that page? Can anybody tell me? It's also right on the board. Joel.
Isn't the random value that's
Yeah. So if you're going to like transfer money, you don't really just want to transfer money out of the blue, right? A user isn't like a typical user from the like, public web page that you're logging in as like a customer at the bank isn't just gonna be like, yeah, automatically just transfer the money to this account. That's not something that they're going to do. They're going to log into the login page, they're gonna go to their accounts tab, they're gonna go and they're going to go through whatever steps they have to do, and then they're gonna get to that call where they transfer the money, right? So how can we force them to go through that process? Because if you're just gonna skip all those steps, you're probably doing something wrong. And if we disallow that, then we can cut off a bunch of the attack surface. So there's this thing called a CSRF token. Essentially what it is it's a random value that you embed in any page that you want. And we go from one page to the next. So in this case, we're adding like another layer on top of that cookie. The cookie proves you're you. The CSRF token proves that you were on the page that you were on before. So if you say that this action can only be done with a valid CSRF token, and you can only get that CSRF token from going to the login page to the next page, and the next page, all those pages in the sequence, each one verifying that you were on the previous one, then you can limit the attack potential to be exploitable, right? I mean, obviously, you can see that, well, I just made a whole bunch of requests in sequence to go and like go through all of these. That's something you can do, but it's a bit harder. It cuts down the accessibility of the attack. Another method on top of that is something called a double submit cookie. This puts a random value in a cookie and a request parameter that you're going to. If those two match and they're both valid, then the transaction works, else it's going to be denied. So to go over the kind of, to finish how like prevents against stuff, there's something called a web application firewall. And it's what it sounds like. It's a firewall, but for your web app instead of your network. So instead of looking at like IPs, ports, protocols that are going on, it can look at the way that you're interacting with the page. If you have a web server, like let's just use the HTTP method, for example. You put your web application firewall or WAF in front of your server. Your server is not configured properly, it accepts like put, delete requests, which shouldn't. Let's say your WAF, which is essentially a proxy, will like deny this. So in this case, you can put the WAF up to say, no, I don't want you to do puts. I don't want you to do deletes. And then if that request hits the server, it's going to be denied by the WAF. So to kind of expand this to like more applicable things, you can do all of your cross-site scripting filtering in here, or all of your escaping, or you can limit based off of where you're coming from, what pages someone is allowed to access. You can do a ton of things. You can make your own custom things. One of the most popular open source web application firewalls is Mod Security. It was built originally as an Apache web server module that functions as a web application firewall. It doesn't have to exist on the server that you're running. It can exist externally as well. And there is an OWASP core rule set that covers basically the OWASP top 10, all the index vulnerabilities and such. With a bit of tuning, you can make mod security work really well. Mr. Pine Sanders is one of the core devs. If you ask him like a bunch of support questions and you're really like interested in how it works, I'm sure that he will be happy to explain something to you. If not, you can go out, play with it. It's free, it's open source, download it, work with it. So, demo time. Today, we're going to have a multiple web application called KitCoin up. It's only supposed to go to kitten.rc3.club. Don't go to rc3.club and mess with us there. Sum it up. Don't be a jerk off.
Like, it's kittencoin.rc3.club.
Kitcoin.rc3.club.
Yes.
You guys are having a book down in RC3Club.
I was going to get to that.
Yeah, we're gonna
This is not that.
No.
This isn't that.
Like cat.
But for your resources, really anything that you want to do, anyone on the lost, they're very verbose in things that they do. Check out Mod Security, the lost core rule set for Mod Security. Once again, if you have money, like $20 I think it is, for Web App Hacker's Handbook.
$1
Like that, there's some places you can go.
Yeah, no.
Places.
Like, any crap.
Small.
That seems
Alright, so just want to go back. This slide
for no reason at all do you ever have to touch RC3Club. I want to make this absolutely sure that everyone hears me, so that I figure out if anyone's doing it, we're going to have a not nice discussion. Okay? So don't attack RC3Club for any reason because you don't need to. And if we figure it out, we're going to be having a discussion that's not very nice because you're not supposed to, and we've given you a scope. However, moving forward, within the next couple of weeks, we will be setting up a separate instance of RC3Club's website for you guys to go and try to break into RC3Club's website. Currently working out with DigitalOcean's security team about how some of you are going to be attacking their web server if they see a bunch of insecure web vulnerabilities and that flying out of web servers to not worry about it. So we're working on that. We're going to have that hopefully by next week, if not the week after. So, and that's going to stay up for a long time. So if you ever want to get into web applications, say whatever in the next couple of years, you can always go to the instance that we're going to be setting up and practice your web skills if you want a real target. So, but again, do not attack RC3Club. I don't want to have that conversation with anyone. So, finally, does anyone have any questions?
Well, if you make a clone site, you should employ GitHubs and pull from.
So that's actually what we're going to do. So our website gets pushed to GitHub. We're just going to pull down it every 24 hours. So you'll always be the most up-to-date current version.
May I just take 30 seconds?
Hi, I'm here representing the Institute of Electrical Electronics Engineers, and we're going to be here tomorrow for a competition that's going on. And I just wanted to say hello and let you know that there's a site out there that the IEEE has a society called the Computer Society, and within there we have a cybersecurity initiative. There are tools in there that are freeware that you'll be able to find, and there's exploits of recent vulnerabilities that have been found in the industry. They put those up there so you can see what they're like. It's a good networking tool professionally. Also, having a membership in the IEEE it allows you to knock on people's doors and learn who they are and integrate and network to get a job afterwards too. It's very beneficial. So check it out, computer.org. Thank you for your time.
So if anyone has any questions, let's go upstairs for demo.
Okay, bye, friends.
So then we're looking for
Adios.
It looks like
It's